Yay! So,
right, hang on.
sorry.
Right, don't need to give this
What
man
do you think
any.
our shirts?
Yes, okay, right. Yeah, what do you think of our shirts, right? Because
Perry has this shirt, by the way.
yeah, I've got that shirt and I nearly wore it tonight. But my feeling is that thank you very much. Right, 10% discount next year for you, right? But the price rise is also 10% next year. Yeah, so. Yeah, no. So I've got this one. I nearly wore it tonight, and we've sometimes been known to twin up on the shirts, but
I wouldn't be seen dead in that.
Yeah.
Sorry.
Yeah. Well, like you say, like you say, we like diversity in shirts, right? So this is the way it goes. Right. Okay. 10 minutes till pizza time. 2 talks to go. I'm going to give Andy all the 10 minutes, right? And then we'll sort out after that, and we'll go from there. Anyway, right. But you really want to hear my story about writing code in 1983. But anyway, hand over to Andy, and he's going to tell you about stuff. Please welcome Andy.
So as Perry pointed out in the beginning, I actually realized my talk title was a bit too long. So I decided to change it to something snappier. But a few months ago, maybe even last meetup, I was talking to Patrick about this. And he asked me why. Why would you want to inspect iOS traffic using JavaScript? Why wouldn't you use a proxy like Charles or Fiddler? And I started off down this route because I wanted to look at what was going on with HTTP2 traffic out of Safari. And most of the proxies you've got do HTTP 1.1 on the end. So you've got this proxy in the middle. It doesn't really tell you how iOS behaves with HTTP2. So, let's start with the demo, because, if you can't crash and burn in front of your friends, who can you crash and burn in front of? And one of the great things about iOS, and where it's far better than Android, is you can actually mirror the network traffic from your iOS device out to another machine. And in this case, yes, you can see it. It's a bit small, so we'll drag it up, but you can, wrong window. Yes. So you can see over here, we've got a phone. It's a real phone. You can see me do stuff. But what we can do is we can actually tell the Mac OS that we want to capture the traffic off the phone. So we can set up an interface on Mac OS called RVI0 in this case. And this is the identifier of the phone. You can go get it in iTunes. You can query out a system profiler. If you've got Livy Mobile on your phone, you can get it from that. And then what we can do is we can use that interface to capture the network traffic on our phone. And I've done this for a number of clients this year. I've done it for supermarkets. I've done it for airlines. I've done it for banks. I wouldn't recommend doing it. If you want to look at network via Wireshark, it's a pain in the ass, but it might be handy to you. So we'll set up a remote capture, and then we'll use Morrison's app. And I chose Morrison's. They are not a client. I did not do it for them. And it's Christmas. No, seriously, I did not do it for this. It was another supermarket. It's Christmas. So what do we need for Christmas? We need some mulled wine. And because the people at London Web Forms are a bit thirsty, we probably need a fair bit of it. Perhaps a bit more. No, there's still beer in the back. And then to go with our mulled wine, it's hungry, so it's Christmas. So let's have some mince pies too. And I can't spell mince, but never do a live demo. But there we have. Let's some more mince pies. Now we got a great shopping order, and we can see what's in our basket. And at this point, we can stop our TCP capture. We've got some data, so let's have a look at it. And this is where you should never do a live demo because you can't type. These work. Yes. Okay. We can see the demo, and it always says this. It always tells you the packet capture stopped halfway through, but we can see all the traffic that the iPhone captured. And that's the pizza. So you can't have mince pies tonight. You can have pizza, but you can begin to see all the things that are app is talking to. You know, it talks to Facebook before it talks to the API, for example, and we scroll down. But you know, it's all TLS encrypted, so we can't look at it, which is a bit of a shame. The other thing I tend to do at this point is I use AT&T's Video Optimizer, because one of the nice things about AT&T's Video Optimizer is you can actually open pcaps in it, and you can begin to get a waterfall. Oh, and it's been nice to see. You can get an idea of what's going on the network, but you don't see much stuff. You can see that Crash Analytics and Facebook normally holds up long connection, and PayPal. But what we can see as we go down Morrison's, and Morrison's stuff often shows up as unknown when you're doing this. It's not just Morrison's; they all show up as unknown. We can see they're sort of doing things like constantly opening TCP connections, constantly opening new HTTP connections, constantly negotiating TLS. But you know, this doesn't tell me much about what's going on in the app. So I go back to the right window. I was thinking about this, and I remembered something that was tweeted last year by Frank Dennett or Vinny Shah about extracting the TLS session keys from memory on iPhones. And this was quite interesting. And they have sample code in there. Unfortunately, I had some challenges with their sample code. But what they used is a dynamic injection instrumentation framework called Frida. And Frida works on iOS, on Windows, on QNX, on Android, and some other platforms. And what they do is they inject a JavaScript VM into your app. And then you can run a script within that JavaScript VM. They use duct tape by default, but I think they also have V8 available. And so there's a number of ways you can do this. You can either add their dynamic library to your own app. If you can re-sign somebody else's app, providing it's not encrypted, you can inject it in somebody else's app, or you can do what I do and have a jailbroken iPhone. So I looked at their code, and you then think, okay, so where can you get the TLS session keys? So Wireshark, you can provide an RSA ID, you can provide it a client random with a master key or a master secret to decrypt the packets. And funny enough, iOS uses OpenSSL, or used to use OpenSSL. And if we look at the function signature for the pseudo random function generator, which generates some magic secrets, you know, amongst its parameters is a master secret and some client server random. So we've got some C code that tells us where we can go and find the pieces of information we need to decrypt our packet capture. And then we write JavaScript. We write JavaScript that hooks C functions. And here's a helper function to change bytes to hexadecimal strings. In core TLS, we're going to go hook the function. Then we have a JavaScript function that actually gets called whenever our C function is called. And some code to, in this case, extract the parameters, convert them to ints. I do some checking of how long the secret length is, how long the seeds are, because you get all sorts of stuff coming through this function. And I'm no TLS expert, so I just picked the easy bits that I needed. Then we go find the seeds, extract them out, convert them to hexadecimal, and finally we send them back to the Python program or the Node.js program that injected them into our VM in the first place. So, you know, what does this do? It means that breathlessly, thanks, Patrick. This is where I've got to get my head in the right place to think. So, you know, what that means is we can set up a packet capture. And Peter is here, so I'm going to go faster. No. Oh. Don't you hate it when the wrong autocomplete comes up? So we'll start the packet capture in a minute. No, because it's called iOS, that's right. Oh no, I've got to type it from scratch. This is what a cheat sheet, eh? This is why you should never do live demo, because you end up typing code instead of talking to the people who, well, come to listen to other people. And you can never type correctly. Yes. Yes. No. Don't you just hate this? No. So, right. Oh, piece is getting really cold. So I've got to, no, it is com.groceries.release. I'm in, look, oh yes, Morrison's fires up. So what I need to do, yeah, but I fucked up. I did it the wrong way around. Right, sorry. Don't do live demos, people. All right, so, right, let's go up here. Mr. Gooding, you can come do a live demo anytime you like. All right, so we've got TCP dump going. We've got, you can see that the app is dumping out the client randoms here, ready for Wireshark to decrypt them. We've still got the stuff in our basket, but I've decided, as Michael Gooding's such a horrible person, he can have some sparkling. No, you can't have some more pizza. No, you can wait until pizza's cold, my friend. That's fine. So there we are. We add some mineral water to our basket, and it's still there. And look, and we'll now kill our TCP dump. And we'll kill this. No. Don't do like that. That's right. Kill this. And then if we load it into Wireshark, I'll get to that bit in a minute. We'll load it to Wireshark and we can provide it with the keylog file. I will get to why we do this. Let's cut short. Look, it looks the same, but look, we've got some green bits, which means we decrypted the traffic. There is a quiz. Your quiz. Look, and we can see, look, not only we decrypted the traffic, we've got.
Has it been any good?
We've got HTTP traffic decrypted, we've got HTTPS traffic decrypted. We can do things like export all the objects ready for pizza. So you can export the image. But so why would you do this? To answer Patrick's very pertinent question. So, no, sorry, there are some things that are broken. It doesn't support TLS session resumption. I am working on that. It's the fact that you have to dereference C pointers in JavaScript, which for those of you about C is a challenge. I've never got it to work with Safari, and iOS 11 has some challenges because I believe they've moved to Libre SSL instead of OpenSSL. But why would you do this? Well, the reason you do this is you find out all the things that are broken in apps just like they're broken on the web, where people forget to compress JSON responses, where people forget to reuse connections, where people forget to optimize images. So because we don't have the tooling available like we do in the browsers, we miss all these things. So the reality is, as much as we can decrypt the packet captures and view it in Wireshark, we don't want to decrypt the package, decrypt the traffic and view it in Wireshark. We need to build some higher level tools on it. Yeah, and with Frida, we can do things like trap NS URLs because Objective-C is a completely reflective language. We can inspect the other parts of the iOS API. And, you know, challenge for somebody, because I'll never get around to it, is build a version of this that delivers a view that you can use in Chrome DevTools. And that's me. Thank you. Happy Christmas.